Welcome to Premath. In this video tutorial, we have got this right triangle ABC such that this angle A is 30 degrees and this side length BC is 8 units. And moreover, a quarter of a circle is placed on this triangle, as you can see in this diagram, such that the radius of this quarter of a circle is 8 units. And now we are going to calculate the area of this green shaded region. And please don't forget to give a thumbs up to this video. So let's go ahead and get started with the solution. And let me go over the quick review. Let's focus on this triangle ABC, and this triangle is divided into two triangles. One is blue, the other one is green, such that this line segment AD and this line segment BD are equal in length. Then the area of these two triangles, this blue and green triangles, are going to have exactly same area. Now let me go ahead and explain it to you pretty quick why the area of these both triangles are same. And now we can see that the both of these triangles have the same height. Let me go ahead and call this height H for this green triangle, and on this side the height is H as well for this blue triangle. And moreover, since these bases are same, let me call this base B for this green triangle and base B for this blue triangle as well. And now let's recall the area of a triangle formula. Area equals to a half time base time height. And now let's focus on this blue triangle. The area for this triangle is going to be a half time base is B times height is H. And now let's focus on this green triangle. The area for this green triangle is going to be area equals to a half time our base is B times height is H. Now we can see that the area for these both triangle is exactly same. And here's our very first step. Let's consider this triangle ABC, and we know that the sum of the angles of any triangle is 180 degrees, and we know that this angle A is 30 degrees, this angle B is 90 degrees, then this angle C has got to be 60 degrees. Therefore, our angle C is 60 degrees. And here's our next step. Let's go ahead and connect these points B and D. Let me just go ahead and connect these 2 points. And here's our much nicer looking diagram. Now we can see that this BC, this BD, and this EB are the radii of this quarter circle. Therefore, we conclude that this side length BC is equal to this line segment BD and this line segment EB. And in this next step, we know that this side length BC and this side length BT are equal. Therefore, this angle C is got to be equal to this angle BDC. If this angle is 60 degrees, this angle has got to be 60 degrees as well. Now we know that the sum of the angles in any triangle is 180 degrees. So therefore, this angle, this DBC is going to be 60 degrees as well. And now since all these three angles are same, so we conclude that this triangle DBC is an equilateral triangle. Therefore, all these three sides, this side BD, this side BC, and this side CD are equal in length. Now in this next step, we know that this whole angle is 90 degrees. This angle is 60 degrees. So therefore, this angle has got to be 30 degrees. Now we can see that this angle A is 30 degrees and this angle ABD is 30 degrees as well. Therefore, we conclude that this triangle ABD is an isosceles triangle. So therefore, this side length AD and this side length BD are equal. Moreover, this side length AD equals to this side length DC. And in this next step, let's focus on these two triangles. The first triangle is ABD, the other triangle is BCD. And moreover, we can see that this side length AD equals to this side length DC. So therefore, we conclude that these two triangles, triangle ABD and this triangle BCD, have the same area according to this fact that I explained during the quick review. And in this next step, we are going to calculate the area of this green region. For that purpose, let's focus on this sector. I just copy it down, this sector BCD, and then I have subtracted this triangle BCD from it. Then I have added this triangle ABD right over here. And then I have subtracted this part, this sector EBD, from this triangle ABD. And we know that this triangle ABD, this one, and this other triangle BCD, they both have the same area. And since both of them have opposite signs, so therefore this cancels out with this one. So we are ended up with this sector BCD minus this sector BDE. And now we are going to calculate the area of these two sectors, and then we are going to subtract. And now let's recall the area of a sector formula. Area of a sector equals to pi r squared times theta divided by 360. In our case, our radius is 8. In this case, our theta is 60 degrees, and this case, our theta is 30 degrees. So let's go ahead and calculate the area of these two sectors. So this is equal to pi times r, in our case is 8. So this is going to become 8 squared times, in our case, theta is 60 degrees divided by 360 degrees. Then we have a minus sign for this one. We again gonna do pi times r is 8, and then square times, this time our theta is 30 degrees divided by 360 degrees. Now let's go ahead and simplify. This is going to give us 8 square is 64 times pi times, this is going to reduce to 1 over 6 minus, over here in this one is going to be a 64 pi times, this is going to reduce to 1 over 12. And now let's go ahead and simplify furthermore. Here 64 pi, I am going to put it in common. I can factor it outside times 1 over 6 minus 1 over 12. And that is equal to 64 pi. And this thing can be simplified as 1 over 12. So I can write times 1 over 12. So we got our reduced answer as 16 pi over 3. And we know our pi value is 3.14. And if we replace this pi by 3.14, our answer is going to be approximately equal to 16.75. So thus the area of the green shaded region turns out to be 16 pi over 3 square units, or in terms of decimals, 16.75 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.